the switching network will be STS. STS is nothing but space time space, and TST or a unidirectional transmission. For both these time switches is a unidirectional transmission. Since PCM transmission system use four-way circuits. Okay, in the first model also we have discussed about the four-way systems. Okay, for transmitting and receiving, we require two wires. Okay, and these switches configuration. There's the STS and TST are the unidirectional transmission. That's why the PCM transmission system uses four wires. Okay, it is necessary to provide the separate path for sending and receiving channels. Okay, it means that require two wires for sending and two wires for the receiving the channel informations. And one way is provide a separate switching network for each direction of transmission. However, they may avoid off by connecting the sending highway of both incoming and outgoing circuit to one side of the switches and receive the highway to the another side. You can see or observe they will make the common. Any one line they will make the common for sending the both the incoming and outgoing circuits. So that's why that is the representation diagram, the bidirectional transmission through the time division switching. There is a one way. Okay, there is a one way is provide separate switching network for each direction of transmission. Similarly, this may be avoided by connecting the sending highway of both incoming and outgoing circuit to one side of the switches and receive the highway to the another side of the circuits. Okay, that will be shown. You can see there is an incoming trend and then outgoing trends. So there is a bidirection. Okay, there is a switch. There is a cross point will be there now. You can see the dotted line will be the box. There is a rectangle box will be there now. That is your cross points. Okay, through that cross point only we can make this a bidirectional path. Okay, it means that only three lines. Okay, by using some three lines we can transmit the receive the information. Okay, see one line will be dedicated for incoming, another line will be dedicated for the outgoing line. Because initially we know that the incoming and outgoing transfer for sending and receiving the information between the two users, we require two wires. Okay, so that is a bidirectional flow. That is a bidirectional flow. That's why there is a make one way, another way of arrangement with the time division network. Okay, the one line they will make the common. We can use that as a receiving and then sending the information. You can see the direction of that incoming and outgoing transfers. Okay, again in a space network, the same speech store address in the times it may be used for each directions of the transmission. Okay, and then connection between the time store text and the trunk and channel Y and another. Okay, same thing here also. For you want to connection, if you make transmitting between these two incoming and outgoing means with a different time slots. Okay, the for connections between the time slot of X on the trunk and another area channel Y. Okay, then the one direction of transmission, the content at the address are written at the end of the time slots X at the beginning of time slots of Y. Okay, then the opposite direction of the transmission they are written at the end of the same time slot Y. Again, it is a read at the beginning of the next time slot of X. Okay, in the STS switches, and similarly in the TST network, same thing here also. There's a two direction must be carried out through the space using the different time slots. Okay, whatever discussed in the previous time space time. Okay, the same thing here. There's a two different time slots are used to carry the information between the two directions. In order to simplify through these space switches, we are using the time slot for two different two directions of the transmission fixed with a difference. And also usually the time slots have a phase difference of 180 degree. Okay, then suppose if we consider suppose we consider 32 channel. Okay, channel with 32 will be the time slots will be actually are used. What is the time slots for transmitting the one direction? Then what is the time slots will be used? Nearly 12 plus 16. That is a 28 is used for the reverse direction. The transmitting is one direction, receiving is another direction. Correct? No. Suppose if you have considered the 32 channel system, then if the time source will be 12 is used for one direction of the transmission. Okay. The time source 12 will be used for the one direction of the transmission. Then the total transmission time source are used for the reverse direction. Nearly 12 plus 16. Okay, that is half of 32 means 32 channel means 16, 16. 16 for sending and 16 for the receiving. Okay, then the total time slot will be used for the in a single in one direction transmission required. Suppose 12 is nothing but for reversing the information from that particular channel, how much time slot will be required? Nearly 28 is used for the reverse directions. Okay, that's an example. See, there's an example I'm given for the circuits for the TST bidirectional transmission system. Okay. Once again, I'll repeat the statement. In case of TST network, okay, speech in two direction must be carried out through the space, okay, which is using different time slots. Okay, then in order to simplify the things through the space switches using a different time slots for different for two direction of the transmission, and one half should be a fixed time difference. And usually this time slot phase difference will be 180 degree for each direction. And then for that cases, we are assuming, suppose we can assume some 32 channels are there, and time slots can use nearly 12 for one direction transmission. And for the receiving, what is the time slot nearly will required? 12 plus 16.8 time slots are used for the reverse. Okay. There is a bidirectional path. Okay, by using this one, we can use of this one. We can use as a bidirectional. Bidirectional means we can receiving and transmitting the information in a same channel, in the same path. Okay, in the previous case, what happened? There is separate lines will be there for sending the transmission, sending the information between the two telephone means two wires are dedicated, means dedicated two wires are available. Another two words for available for receiving the information between these two users. Now make a use of this one. Okay, we can use the same lines can use as a transmitter, and the same lines can use as a receiver. Okay, in the TST and STS switching network. They will modify that one. Actually, these are modified switching network because of earlier STS and TST are unidirectional transmission. Okay, to overcome this one, we do the modifications in the network. Okay, what you are seeing in the diagram, there's a bidirectional transmission through time time division switching network. Okay, clear? Any doubt?
No, sir.
Okay. Clear about this one? Any doubt regarding this? Okay. Then the next important topic. Synchronization network. Okay, we are moving to the next important topic. There's a synchronization. Synchronization means See, some of the network, some of the user are connected to the particular local exchange. Some of the user can connect with a different local network. Okay. See, suppose we take an example, the user A will be in one local network and user B will be another local network. Okay. How the connection will be happen? Okay, during the connections, the both the local action should be synchronized. When it is synchronized only, we can easily transmit the information without any noisiness. Okay, that's why before transmitting and discussing the information between these two local exchange users, between the different local exchange users, we should make the before the particular local exchange should be synchronized properly. Okay, synchronized. Then only we can easily transmit the information between the users. Okay, clear? See, but each local exchange is having a different set of frequencies will be there. Okay, we should match the frequency before connecting the lines. See here, coming to that synchronizing network. Okay, actually synchronizing is a digital network. Just one or two atomic reference clocks control the frequency of the clock. Of all exchanges in the network, this is called a despot control. Okay, synchronizing links may be unilateral or bilateral. Unilateral means one thing. It means only one telephone exchange will be synchronizing the particular frequency. Bilateral means both the local exchange will make the synchronizing the frequency. Okay, synchronizing links, it may be unilateral. We'll tell that what will be unilateral and what will be the bilateral also. The first case, suppose a unilateral means one telephone exchange will be act as a master, another telephone exchange will be act as a slave. Relationship. Okay, and then the clock frequency of the exchange influences the frequency of the other one. Okay, that is the first stage. Okay, it may be unilateral or it may be bilateral. Okay, for this purpose, we can see this figure also. Before going to that, you can see the figure. See here, these are first cases. Okay, one is acts as a master and another as a slave. Okay, so before going to that, why are you using this synchronization? The purpose of synchronized network is to be added the PSTN in order to link the exchange the clock to the national reference standard. Under the normal condition, the network will be free of state. Whereas that's a unsynchronous. Okay, unsynchronous network will have you will always experience the same step. Step means there is a difference between the frequency. Okay, step is nothing but some difference between the steps. See, one telephone network will be active with a different frequency. Another telephone exchange will be working with a different frequency. Then what? Suppose if you make the connection between these two users. Okay, suppose the local exchange user should be connected to the local exchange B user, but these two local exchanges will be having a different set of frequency. So before connecting, then these two local exchanges should be synchronized properly. Okay, that thing will be done by either using a unilateral or maybe a bilateral way. You can synchronize the frequency between these two telephone exchanges. Okay, under normal condition, there is no sleep, there is no sleep is nothing but there is no difference in the frequencies. Whereas if you go for some synchronous, this the asynchronous network, it is also some experience of the sleep. Means there is a difference between the frequencies. Sleep is nothing but there is a you take an example of a motor. Okay, you take an example of electrical motor, any induction motor. Okay. During the no load condition, we are not applying any load means the speed of the motor will be near to the synchronous speed. Okay. Suppose the rated of the motor will be 1500 RPM. RPM. If suppose there is no load, we are not applying any load to the particular motor means the motor will rotate at the same speed only 1500. Suppose if you add some load, put on some load on the motor, what happens? Gradually decrease the means there is some variation in the speed. Okay, if you put on 50% load, the speed will be again. So the speed also will be decreases. Again, if you put some 100% of load, again the speed will be decreases. Then what is the difference between the speed between the no load to load condition? Then some speed will be variation. Okay, that is called as a slip. That is called as a slip. That is also called as a. There is a difference between the load and no load speeds. Okay, and suppose you in the no load condition it is operating 1500 RPM. Suppose if in case of full you are applying some full load to the particular motor means the speed will be decreases. It nearly is running at 1400 or 1450 RPM. There's a 50 speed, the 50 RPM will be variation. That is the called as a slip. Okay, here also in this case, in the DSS case, the each telephone exchanges will be operated with a different frequency. Okay, before transmitting and receiving the information, the both the telephone exchanges should be match the frequency by the different cases. It may be unilateral, it may be bilateral way we can match the frequency of the two telephone exchanges. Okay, that's why some of the other there's a Basic synchronous network is always some experience of skill. The local clock in each exchange is provided by a crystal oscillator whose frequency can adjust with the control voltage. Okay. They are using some of the crystal oscillator to adjust the frequency. And then the control voltage is derived from the incoming registry on synchronizing link, which is used to determine whether exchange clock rate should be increased or decreased or left unchanged. Okay, based on the incoming registry. Okay, the control voltage, how to get this control voltage means we can vary the control voltage. We can that's why this voltage, this control voltage will be derived from the incoming digistream or synchronizing link. Okay, then we can use to determine the whether exchange will be clock rate will be increased or decreased or remain unchanged. Okay, this adjustment are made periodically. Okay, this adjustment are made periodically as a single quantum increase or decrease. This ensure that exchange maintain the same long term average frequency, although short term deviation may occur. This is known as a mesosynchronous voltage. Okay, then we have different types of synchronizing links are there. Digital network. Okay. It may be a bilateral or it may be a unilateral. A synchronizing link may be a bilateral or unilateral. Sir? Okay. See, actually, the synchronous link. Okay. See, initially I told you, the control voltage will be derived from the synchronous link. Okay. These synchronous links may be unilateral or bilateral. Okay. In the first case, suppose you can consider it the unilateral. There's nothing but it's the master slave relationship. Okay, the clock frequency of next that one the link is controlled by the slave by exchange to the another. Okay. You can show the I will show the figure of these the first case. There's the unilateral. Now it is visible now. Now it is visible, dear students. See, this is a master and slave. Okay. Suppose in this case, the second case is a mutual relationship. Okay, this is second is a mutual relationship. Each section influence the frequency of the other. The first case is the master and slave relationship. Okay, the link will be maybe unilateral or bilateral. Okay, suppose first case I'm considering the unilateral. The same thing, unilateral also will be first case will be master slave relationship, otherwise mutual relationship. Similarly, bilateral also there is a master slave relationship, otherwise mutual relationship. Okay. In the first case, you can see observe here, there is a master slave relationship. The exchange A is the master and exchange B will be the slave. See the slave, the exchange B is the slave now. The exchange B determines the phase difference between the own class and that of exchange of A by the filling the random buffer of the incoming. Okay, that's why they are using the exchange B. They are using some phase compensators to synchronizing the frequencies. Okay, that's why this exchange B is to determine the what is the exact phase difference between its own clock and then exchange B. Okay, then how to synchronize means to filling the align buffer on the incoming line. Filling some align buffer on the incoming. Through that one, we can synchronize the both the exchange A. Okay, the change in phase. Okay, how to change in phase? Step increases, decreases in clock frequency. Okay, lasting for a few milliseconds. In a 5 milliseconds, you can step increase or step decreases the clock frequency. Through this, you can synchronize the lines between the exchange and exchange. Okay. Okay, clear about this one? Clear about this one?
Yes, sir.
ಓಕೆ ಇಟ್ಸ್ ವೆರಿ ಸಿಂಪಲ್ ನಥಿಂಗ್ ಎಲ್ಸ್. ಇನ್ನೊಂದ್ಸಲ ಹೇಳೋದಾದ್ರೆ ಕನ್ನಡದಲ್ಲಿ ಹೇಳೋದಾದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಈಗ ನಾನೊಂದು ಟೆಲಿಫೋನ್ ಎಕ್ಸ್ಚೇಂಜ್ ಎಲ್ಲಿ ಇರ್ತೀನಿ, ಇನ್ನೊಬ್ಬ ಟೆಲಿಫೋನ್ ಎಕ್ಸ್ಚೇಂಜ್ ಬಿ ಅಲ್ಲಿ ಇರ್ತಾನೆ. ಅವನು ಇಬ್ರು ಕನೆಕ್ಟ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ, ಲಿಂಕ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ, ಐ ಮೀನ್ಸ್ ಕನೆಕ್ಷನ್ ಆಗ್ಬೇಕಾಗತ್ತೆ. ಕನೆಕ್ಷನ್ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ ನಿಮ್ದು ಏನ್ ಡೇಟಾಸ್ ಇರುತ್ತಲ್ಲ, ಆ ಡೇಟಾಸ್ ಟ್ರಾನ್ಸ್ಮಿಟ್ ಮಾಡಿ ರಿಸೀವ್ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ ಆ ಎರಡು ಫ್ರೀಕ್ವೆನ್ಸಿ ಮ್ಯಾಚ್ ಆಗಿರ್ಬೇಕು. ಓಕೆ, ಮ್ಯಾಚ್ ಮಾಡೋದು ಯಾವ ತರ ಅಂದ್ರೆ ಯೂಸಿಂಗ್ ಯೂನಿಲೇಟ್ರಲ್ ಆರ್ ಇಟ್ ಮೇ ಬಿ ಬೈಲೇಟ್ರಲ್. ಓಕೆ, ಇಲ್ಲಿ ಯೂನಿಲೇಟ್ರಲ್ ಏನಿರುತ್ತೆ, ಮಾಸ್ಟರ್ ಸ್ಲೇವ್ ಅಂದ್ರೆ ಒಂದು ಮಾಸ್ಟರ್ ಆಗಿರುತ್ತೆ, ಒಂದು ಸ್ಲೇವ್ ಆಗಿರುತ್ತೆ. ಸ್ಲೇವ್ ಮುಖಾಂತರ ಅದನ್ನ ಸಿಂಕ್ರನೈಸ್ ಮಾಡೋದಕ್ಕೆ ಇರುತ್ತೆ. ಮ್ಯೂಚುವಲ್ ಅಂದ್ರೆ ಮ್ಯೂಚುವಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ಓಕೆ, ಎನಿ ಒನ್ ಕ್ಯಾನ್ ಡೂ ದಟ್ ಒನ್, either can A or it can be mutually relationship. You can match the frequencies. Okay, in this case ಏನಂದ್ರೆ in the first case whatever does the slave and master and slave. Okay, master control is nothing but does the main exchange is the master and exchange B is the slave. Okay, yeah, the exchange B is determine the phase difference. What is the phase difference? So what is the difference between the lines that will be identified, and that will be determine the phase differences between this exchange B and exchange A, and by adding some align buffer to the incoming link. Okay, this can be happened by using the clock frequency. You can increase or step decreasing then the clock frequency. Okay, lasting for within a few milliseconds, you can increase or decrease the frequency. Then we can synchronizing the network between these two telephone exchanges. Okay. Okay, dear student, today we'll stop here. We'll continue the next class. Any doubt regarding this today's section? You can ask me a question. Hello. Any doubt regarding this today's session? Yes, sir.
No, sir.
Okay. Again, next class, again the second piece will be there. We'll discuss in that. Okay, today we'll stop here. Okay, thank you.
Thank you, sir.
Thank you, sir.